Welcome to our presentation about working collaboration between Berkeley data science modules and political science. I'll be presenting Eric Van Duzen with David Broockman and Andrew Little, who are professors in political science. And we also have colleagues Balaji Alwar and Elias Saravia from data science undergraduate studies. Here's everybody introduced and our titles. Just to introduce ourselves from data science undergraduate studies, we have a team of students that work to help build Jupyter notebooks for all sorts of classes across campus. And we've really been enjoying working with the political science professors. Our vision is that students all across campus should have the capacity to touch and learn from data science.
To explore a little bit more about what a module's curriculum typically is, it's an introduction to data science and gives students an opportunity to work hands-on a specific data set of interest within their own course. This could be manifested in the form of laboratory assignments, homeworks, projects, or lectures, all in the context of the course. And we usually use Juptyerhub or Datahub to help relay all of this information. Students are given the opportunity to learn principles of data science, statistics, computing, translation of data visualizations, and get them more interested into what, for example, in this presentation, what political science and data science, the intersection between them kind of looks like. And some collaborations that we've had within political science are Poli-Sci 3, Poli-Sci 5, and Poli-Sci 88. And to look more about our performance as modules and connectors and how we've performed over the years, over 5 years of creating curriculum, we've already served over 13,000 students. We've worked on over 80 courses, created over 250 notebooks, and served over 40 departments, including economics, ethnic studies, sociology, biology, and more. Specifically looking in the context of political science, we started our collaboration in fall 2019. And since then, we've served 1,380 students approximately. And we've worked on 3 courses, which we hope to expand. Should you give us an opportunity to work with you, and created approximately 15 notebooks. Some of these courses, as I mentioned before, Political Science 3, Political Science 5, and Political Science 88.
Awesome, thank you. Balaji, you want to jump in?
Yeah, sounds great. So what is Datahub? I know Eric could talk about this hours and hours together. So Datahub is Berkeley's instance of Jupyterhub. So Jupyterhub is the online compute environment for running data science workflows for instructors, students, researchers. So it started out a few years back. It was the platform was specifically built for data aid, and the vision was inclusion and accessibility. Like any student, irrespective of their background, can take up data science courses and can run data science workflows. So it was built to be scalable. As you can see right now, Data it has almost 1,500 students who are working on using the Datahub as part of their work. So the core philosophy behind this work is open source. There is a free textbook for data aid. There is this open source software which we have which is the Datahub, and also the curriculum is open source. And this particular tool could be extended to multiple different domains. As you can see, political science is one example. So we also have instructors from genomics, biology, public health, physics, computer science, and so on. Next slide. So some stats about Datahub. So on an average, we have 4,000 users who are visiting the platform on a daily basis during weekdays. And we have almost 10,400 plus users on a monthly basis. As I'm talking, we have more than 60 plus courses across the campus using Jupyterhub during fall 2021. And a back of the envelope estimate is that most students are spending close to 10 plus years of worth of their time in the platform. And this is something this statistic is something we need to validate further. And one of our colleagues did some analysis on the cost for using Datahub, and it is around $3 per semester per student.
This is back to me, I think. So we started working with the political science department in 2019 with Poli-Sci 5 and with Poli-Sci 3. Poli-Sci 3 was with Jason Wittenberg, who had a set of sort of static slides that were presenting like regression output from Stata, and we worked to sort of make those appear in the Jupyterhub. Since then, there's been 2 more iterations of Poli-Sci 3. And if we share the slide deck, you can click through and see those notebooks here. And then currently Poli-Sci 88 is being taught, and we'll go into depth on each of these classes. So originally Poli-Sci 3 was being taught in Python, standard aspects of quantitative methods in a required class. That's about 300 students each semester that it's taught, and some great applications with great data sets about applications to political science. This current semester, we've moved on to having Poli-Sci 3 being taught in Jupyter-R. And there's a lot more notebooks and more sophisticated treatment of the statistics and more techniques taught to the students. And I will turn it over to David to talk about his class.
Yeah, thanks so much, Eric. So if you go to the next slide.
Okay.
Okay, so, this is just more examples, but sorry. So, okay, here we go. So here's how it works. PS3 Fall 2021. So in addition to using Jupyter notebooks, I'm sort of not just using them, but the whole class is really based around them. And I'm doing this with an approach called flipped classroom, which I'm sure people have heard this buzzword. And the particular flavor of flipped classroom I'm using is an approach called team-based learning. So if you go to the next slide. So the way it works is before class, students have to watch a video. So every single class, there's a video they need to watch beforehand. These vary in length from 15 minutes to 45 minutes. Usually it's around like 20 to 25. And this essentially will teach them the key concept that they need to know for class. And so they do this before class. It's usually a mix of how to do something in R, like take a difference of means between 2 groups, as well as like the conceptual underpinning of like, why are we doing this? So you go to the next slide. So that's what they would do before class. Then on Tuesday, so my class meets Tuesday, Thursday. On Tuesday, the first thing they do is they show up to class, and rather than having me lecture, they have an individual assignment to do. In the language of the team-based learning paradigm, this is called an individual readiness assessment. And what they do is they hop into a Jupyter notebook, and they usually have about half an hour to answer a few questions in that Jupyter notebook. Because of the COVID restrictions, how big the class is, it's been on Zoom. And so the way I set it up now is that for every question, there's a separate breakout room. So if you're doing the assignment on your own and you're like, oh, I got to question 2, I'm really confused, you can hop into the question 2 breakout room and ask a question. Then when we move in person, I think there'll be like corners of the room where they can like go take their laptop and say like, hey, like I'm confused about this question. So again, they would have watched a video where I'm sharing my screen going through what I call a lecture notebook beforehand, but they would say like, here's how to do this. And then they'd have to apply it in some new way in the next one. Okay, next, Tuesday part 2. So the first half of class, they're doing things on their own. The second half of class, or I guess the second third of class, they then answer the exact same questions, but in a group. So they turn in their individual answers, then they get in small groups and they have to redo those questions and do it as a group. And this time, the assignment tells the students whether the answers are correct or not. So if the students had different answers, they can like say like, I think it's this, I think it's that. Let's see, let's try this. Oh, it turns out that's wrong. Like, let's try your answer. Oh, that was correct. Like, why is that? So they're kind of comparing answers, seeing what's right and wrong. It's really cool that the notebook can tell them if it's right or not in real time. Then at 6:10, everyone turns in their group notebooks and I go over the right answers with the whole class. And then their grades are usually returned like essentially instantly. So they get this very rapid feedback on like, do I understand the concept? I used the concept, was I right or not? Then I'll also have, if you go to the next slide, another video before class on Thursday, where I'll kind of build on that concept in some way. And on Thursday, it's all group-based and it'll be more open-ended. So in addition to some coding, I'll have them answer open-ended questions where they'll have to say like, okay, here's an estimated p-value, interpret like, what does this mean? Or based on run these 3 lines of code to do these different comparisons. What do you think we've learned from this data set? So the coding questions will tell them whether they got the answers right or wrong, but then there's open-ended questions, and the GSIs will kind of go around to the groups are formed in sections, and so if there's a group that has a question, the GSI for that group will go to that group and help them answer the question. And then there'll be a GSI assigned to grading. And so as they're turning in the assignment through the class, the GSI will be grading. And so they usually get the grades back, again, like within 30 minutes of the class ending. So it's like very, very quick, rapid feedback on like, okay, are we understanding this concept or not? Do I need to go like rewatch because I'm not getting it? So you go to the next one. There's also problem sets. And the problem sets are also all in Jupyter, and some of the questions will tell the students if they're correct or not. Most of the questions don't do that. The thought here is like, if you have questions 1 and 2 to understand what's in a data set, and then question 3 asks you open-ended to interpret it, like we want them to make sure they actually got the right coding stuff first, and then they can try to interpret it. So there's 4 problem sets over the course of the semester. Also, again, all in Jupyter notebooks. Awesome tool to allow them to figure out if they have the coding right, but also like interact with the data themselves. And then you go to the next slide. There's also a final project where they have to come up with their own hypothesis, gather their own original data, and then analyze it in their own notebooks in groups. So these are going on right now. It's been really fun. They can work on essentially whatever they want. It doesn't have to be that political science. And so we have students who are doing experiments on like, if we give people different messages about what's happening with the development in people's park, does that change their views? We have some people doing some real world projects. So we had a student standing outside of Cafe Strata, I think asking people if they wanted to watch anime or something like that, and like seeing what predicted whether people would agree to watch anime, silly things like this that and then they have to like take that data, import it into Jupyter notebooks and analyze it themselves. So that's another Jupyter notebook based project. So next slide. I think, okay. The last thing is, so far, this is from the mid-semester non-anonymous evaluations I did. So we'll see how the final course evaluations go. But overall, the students said they felt like they learned a lot on the course. They didn't think it was moving too fast. They thought it was more fun than they thought. They liked the format. They thought the content was useful and interesting, and the class was organized. I think qualitatively, one thing that my sense of like part of what's made the students really like the class is that they all come in, to be honest, quite intimidated by the idea of coding. And so they're like, oh my gosh, I'll never be able to do this. But then as soon as they start to dive in, I mean, Jupyter Notebooks is really, it's like you put someone on a set of training wheels and you're holding the handlebars, on a tricycle, and you're helping them move. And so because there's so many guardrails where they can get started with coding, you're really not throwing them in the deep end. And so I think once they realize and there's some trust established in the first couple of weeks of like, oh, actually, like this isn't so hard, I'm getting the help I need to do it, all of a sudden they're like, wow, like I can do this. One of our undergraduate staff members told me that our staff members who advises the undergrads told me that one of the undergrads went into her office and said, I'm coding, can you believe it? And so that's the kind of thing that I think we want to see. And in a world where like all these students recognize that coding is like really important, but a lot of them feel like it's not for them or it's not useful. I think they come away feeling like, oh wow, not only is this useful, but like I can do this. And so I think that's really good. Okay, if you go to the next slide, is that it? Okay, lessons learned. Yeah, so the Jupyter notebooks definitely work at scale. I think, I taught a class sort of like this at Stanford when I was there, and we didn't have Jupyter notebooks there. And one of the big challenges was that, every student has their own, like, R studio and like computer problems. And there's just so much time that you have to waste on dealing with like people's idiosyncratic computer issues. And so this just really reduces the amount of time you have to spend on that. And it's going to work. The flipped classroom, I think, also is really synergistic with this Jupyter notebook model because you can debug issues and misunderstandings live in class. So the fact that like the lecture part happens outside of class and like during class while they're coding, they can like get real-time feedback on like, oh, I have this problem, like, there's like little minor issues that people run into when they're coding for the first time. I think it's nice to have that happen during class time when someone's there like to help them and they don't have to like wait for office hours the next day or whatever else. To be honest, my main takeaway is that the students pick up coding faster than I and they thought that they would. Like if anything, I would probably make the class a little harder next time. And the flip side is I do think the students have been slightly slower than I expected on some of like the conceptual stuff. And so one of the things that I'm planning to do next semester that I teach this, which is next semester, is to add in more kind of like multiple choice questions in the notebooks to say like, okay, do you understand this concept? Is it A, B, C, or D? And they have to like, tell me which it is. So that's one thing I'm planning to do now that I have this experience. Like that, frankly, their grades are higher than I thought because they're doing much better than the coding than I thought. But I need to add in more questions on the conceptual stuff where I think they, I had like maybe less emphasis than I needed to because I didn't estimate like where the difficulty would be exactly right. So the coding part I think is actually not the hard part.
And if you coded up multiple choice questions with Otter, you could give them that real-time feedback. Like they would immediately know what. Okay.
Yeah, that's right. That's right. There is one piece of, so the traditional team-based learning paradigm, there's one piece of it that I don't think the technology currently allows us to do, which is in a traditional team-based learning, you get a scratch-off card. And so like where it'd say like, A, B, C, D, E would be the answers. And like say the right answer is B, but you essentially first scratch off A and then it tells you, oh, sorry, you're wrong. And then you can answer B and you get like partial credit. So that would be like, I think that's too complicated for us to do. So I think the multiple choice questions are a little tricky because they could just like keep guessing until they figure out what the right answer is. So I tend to not tell them what the right answer is for that one, just because like it's too easy for the students just to like keep trying every option.
Let's ask Chris Piles. He'll figure it out for us.
Yeah, you could imagine in the future, one thing we could do is have something where like it's costly to them, where like it's better for them to get the right answer first, but then they get partial credit if they get it on their second try or something like that. So that's one thing where the technology doesn't quite do what we want, but it's not such a big deal.
Nice. Thank you. Fantastic. This is super helpful. On to Andrew.
Great, thanks. So the class that I've been teaching this semester is, in a sense, a new version of PS3, which David just talked about, where the idea is to make it a connector course with Data 8, meaning the students need to be either concurrently enrolled in Data 8 or have taken it before. And so the idea of what I get out of that and what the students get out of that is that since Data 8 covers a lot of the material from PS3, things like the basics of coding, hypothesis testing, a lot of basic statistics, in PS88, we get to focus more on sort of other stuff that's relevant to political science. And so broadly, we can lump that into, we get to spend more time discussing formal theory and game theory, and we get to spend more time discussing causal inference, which are sort of two of the key quantitative methods that are most common in the discipline these days. So another nice thing is for better or worse, we sort of get a slightly different set of students. So there's a little bit less of the coding phobia that we see in PS3, because it's sort of a set of students who select into wanting to take Data 8. But there's still quite a bit of heterogeneity. There's some students who are just super, have super strong coding backgrounds. Other ones who are a little more hesitant, but we're at least willing to take Data 8. So it's been helpful to kind of have that more common baseline that no one is like totally frightened by the idea. So my class has been structured a little bit more like a standard class. So we meet for 2 hours a week, or hour 50 minutes a week. Typically spend a little bit over an hour lecturing, often with a bit of Jupyter notebook work interspersed in. And then every week there is a lab, which is due the day before class next week. And so we usually like to spend about 40 minutes in class, either starting working on the lab altogether and then letting them sort of break off into pairs and work on it as well. And so these weekly labs are really the bulk of the assessment in the class, but we're also doing a sort of a 3-part project where first they read an existing paper and discuss some of the theoretical aspects of it. The second one, which they're working on now, is I've created notebooks that help them replicate some of the key results from the paper. And then in the third part of the project, with a lot of guidance, we're going to help them kind of merge in some new data to extend the analysis of that existing published paper. So next slide. So just a couple of things about like why it's been really fun for me to teach in this way. So one way is, so I'm primarily a game theorist, and that's like mostly what I've taught through my career. And teaching this in Jupyter notebooks has like actually totally changed how I think about teaching this subject. So it's usually very algebraic the way we teach it. So things like what does it mean to have utility? So we often talk about, okay, people have preferences over choices. And then we prove results like, oh, well, if people can compare individual pairs of choices, there has to be some best choice, which is at least as good as the others. And so a fun thing that we can do in a Jupyter notebook is essentially like implement an algorithm to prove that. So rather than just like describing this again in algebra, I like make a little table that says, okay, here's all the possible pairs of candidates. And, do I like candidate 1 better than candidate 2? And then we can effectively prove what's called the theorem of the maximum, like by writing a function that does these comparisons for us. So I think this has been just sort of a neat new way to teach a subject that I, been teaching for a long time. That there's no way I would have thought of this without teaching in this way. Some other kind of theory ideas that work well here is like the famous Schelling segregation model is a fun one to implement here. Another one is sort of the question of simulating the probability that your vote matters in an election. Again, like something we can do with algebra, and we do it with a bit of algebra. But then another thing you can do is just write code to simulate a bunch of electorates and count how many times the election is tied. So there is sort of a kind of thing which works very well with simulation. Next slide. So the next thing that again, it's also like changed the way I teach certain things is I think this method of teaching has helped build much stronger connections between the theory part of class and the data part of class. So when I teach game theory, rather than just doing hypothetically, here's the prisoner's dilemma, here's the Nash equilibrium, what I do is, in addition to teaching that and some extensions of the theory, I do a survey of the students in the class and ask them would they cooperate or defect in different scenarios. And then we can just immediately pull up the data of their surveys and see if it's consistent with the theoretical ideas that we developed earlier in the class. There's also a neat one with the ultimatum game for people who know that. This is there's $1, I make an offer of how to divide it, you can accept or reject. And so again, we like do a survey, ask students how they would play this game, and we can do things like compute what's the optimal offer to make if you're matched with a random member of the class. So again, there's like an immediate connection between the theory we develop and what it looks like in some real survey data. Then we can do some similar things with real political science examples. So median voter theorem is sort of a famous result about predicting whether parties are going to converge to what the median voter wants. We sort of create some theories about how parties might compete and what positions they take, and then use the data science tables, produce some tables of simulated data, and then go check what the real data looks like. So it's sort of a really nice, seamless way to go from theory to what we observe in the data. So next slide. And then, yeah, so just quickly overview, the way that I'm teaching causal inference is sort of pretty similar. We can think about like, okay, if there's certain different processes that generate this data with different causal processes, what are we going to observe in reality? So we can sort of simulate some data, and then see, using our methods of causal inference, can we sort of figure out what the real causal effect is in a simulation, right? And then we sort of take what we learn from that, and then again go to some real data. So next slide. Yeah, so I think on the whole, with the exception of some kinks to work out, I think this has been a really satisfying way to teach. I want to say it's just to set expectations. It's like, particularly if you're going to do a lot of these notebooks, it's a lot of work to make good notebooks. So getting good data, cleaning the data, getting in a way that's going to be pretty seamless for the students. There's just like a lot of writing and a lot of writing questions that need to be very clear. And so I think I've sort of got better at this as the semester has gone on, but I would just sort of flag that it's more challenging. Depending on how you do it, it can also require a lot more grading. So it's important to think about strategies for that. And for other people who want to do other connector courses that are matched with Data 8, there is a bit of a challenge that there's going to be some students who are taking it now and some students who took it maybe even 2 or 3 years ago. So there's some issues of calibrating that. But sort of through all these challenges, there's like really fantastic support. So every time I've had an issue come up, you throw up an issue on GitHub and the people in this call like solve it within 24 hours. So so there's tons of great support, and on the whole, I think it's a great experience for the students.
What about some things are in data science and some things are in pandas? The
Yeah, so
age-old complaint of the connector instructor.
Actually, no. So that's actually been less of a problem than I expected. So, so for those who don't know, there's so the data science libraries are ones that were built specifically for Data 8. And so what I've done is for the first maybe 7 or 8 weeks of class, I just stuck with that because that's what they were learning. But for a lot of, if you want to do regression, if you want to do a lot of other sort of more advanced statistical concepts, just the data science doesn't work super well. So we effectively sort of halfway through did a transition to using some of the more industry standard tools like pandas. And to be honest, I was worried about this and it really hasn't been well. The students seem to have picked it up well.
Nice, nice. Thank you so much. I think we just have a few more slides to wrap up. Elias, did you want to talk about when you worked on PS5?
Yeah, Political Science 5, it was a great group. Most of the students didn't really have much of a technical background. They might have been seeing Jupyter Notebooks for the first time. I've worked on this project alongside Alia Madanak in fall 2019. Number of students was around 325. The main takeaways for the students were to look at data visualizations and gain some data literacy, understand and communicate what the data is trying to say, maybe look at a certain table, see what does a row represent, what do certain columns represent, how are things coded, what is included, what is being excluded in certain data sets. Specifically, we looked at the civil conflicts analysis using the Uppsala conflict data program and the Department of Homeland Security for immigration statistical analysis. On the top right, you could see students had the opportunity to select a country of interest represented in the data set of civil conflicts and conduct their own analysis in a write-up. On the bottom right, students got to select a year and compare the number of conflicts between minor and major wars globally. And then on the bottom left, students got to look at immigrants admitted into the United States based off of the Department of Homeland Security data set. And that were admitted as refugees and asylees based off of country. And you can see a high number of immigrants around 2006 from Central American immigrants and growing after 2015. And students got to make the connections based off of what was taught in lecture on connections to the El Salvador gang truce and the Mexican drug war influence on this.
Cool, thanks Elias. I also want to throw up a slide for like an awesome student who William McEachen, who graduated in the last year, is now working like at a political science data science startup. And it's also just important, like he really leaned in and helped these first efforts and helped, build out the first Jupyter notebooks for the PS3 the first time. He was a part of our modules team at Data Science Undergraduate Studies. And was part of the community of students. He ended up leading a team that was helping to build the PS88 notebooks. So just an awesome part of the program is the students that lean in and get really excited and passionate about building this curriculum and can help professors build curriculum or get started on the pathway towards building curriculum. If you're interested in data science modules, you can fill out an interest form. You can email us directly. There is a book that's sort of like a guidebook that sort of explains a lot of the things that you would need to know along the way. You can also go and look through the Jupyter notebooks that are already built and the ones that are on this call that are being served to classes. You can look through those in public repositories and get to know them. You can also email myself or Elias if you want to engage about this. And then we would love to get feedback from you guys about what's possible classes that might want to be using Jupyterhub in or Datahub. These are some that we've gotten from political science students that we know that are like being taught in our studio or being taught elsewhere. And like, are there folks we should follow up on directly? So, yeah, David.
Yeah, just to give you a sense, you guys, and then also our department, a sense of kind of where we're going. We've sort of told in political science, we've told our department about this some, but to reiterate it, so we have like a tiny bit of money from a grant that Andrew and I applied for and did not get, but they gave us like a consolation prize to essentially support faculty either with their research account, which they can pay themselves summer nights, and or to hire or summer money. It's not enough for a whole summer ninth. Summer money and or hiring graduate students to help them develop courses. And in particular, I think, as we think about with our diverse student body, how to become more of a pipeline for PhD programs, and also how to get our students into, higher paying jobs. I think it would be good for them not to just do PS3 or do PS88, but have follow-on classes they can do. Both for their own sake, for the educational sake, and there's another carrot we can give our students, which is those classes can serve as approved electives for the data science minor, and that will allow us to essentially lay out a roadmap for our students who are political science majors to, with not too many additional classes, get a data science minor. So Gabe Lenz is planning to do a class about crime and democracy next year this way. And we have other faculty in subsequent years who we think are interested in this as well. So the hope is essentially we'll have, even if the median student doesn't want to go this route, with a major as large as ours, if 20% of students want to go this route, it's a huge number of lives that we can touch and give people serious skills. And so our hope is to kind of create that pathway and classes after PS3 and PS88. And for professors, I think part of what's nice about it is that I think oftentimes professors want to engage more seriously in like data and like the real science of what they're doing, but they feel like if students don't have the quantitative background, they can't sort of go there. But if you have a student who's done well on PS3 or done reasonably well on PS88, you can be confident that they're going to know enough that you can kind of hit the ground running and not have to reteach them like what's a standard error, how do I open up R, things like this.
Fantastic. Thank you so much. One other thing I just want to give a quick shout out is DS Undergraduate Studies also has a discovery research program. So you can get all sorts of data science students to sort of like volunteer on a research project. And there's a whole matching part where, professors or somebody at an institute can come with a research problem, and DS Discovery team can match students based on skills to your project, and you meet with them periodically over the course of the semester, and they can contribute to a research project or work through a data set that you haven't gotten to yet, or help to wrangle some data that needs work before you do the final analysis. So hopefully there'll be many professors that will be interested in getting sort of like data science help on existing projects. So that's it for us. I don't know, Andrew, did you want to say anything to wrap up, or?
No, I'm not sure anything else. I mean, I maybe like an additional pitch is I'm probably going to be developing a new undergraduate class in the next few years, and I mean, I'll definitely be doing this. I mean, I think it's just a fun way to teach, and as you said, it's just giving our students a lot of skills they need. So. I'll vote with my feet, as we say.
Awesome. All right, thanks so much. I really appreciate all this engagement from you guys, and I really hope it pays off long term for the political science department. You're going to have more qualified students than ever before.
Part of why we can do what we do is that Eric, you and your team, and everyone with Datahub, with Otter, like all of these people in this ecosystem have just been so amazingly helpful for creating the ecosystem and then supporting us as we go ahead. So thank you.
Okay, fantastic.